Hello, my name is Fracozet Alenyabon. Today's video is the first video of my course project, Data Communication and Networking. The topics are network fundamentals, network types and topologies, network models. Network fundamentals, computer network, is a group of computer system and other hardware devices that are linked together through communication channels, facilitates communication and resource sharing among a wide range of users. Example are the switch, fires, and the firewalls. Network types. Computer network are classified based on the certain criteria. Based on the trends, computer network is divided into two: the wired network and the wireless network. In wired network, all systems are connected via communication channels and cables. In wireless network, radios, waves are used to form a network. Based on architecture, a computer network is divided into two: peer-to-peer, client to server. In peer-to-peer network, there is no centralized administration. All computers in the network are independent. In client-server network, there is a centralized administration. Server-controlled clients network are classified based on geographical. The first one is the PAN, which is personal area network. The second one is the LAN, the local area network. Third one is the MAN, the metropolitan area network. 4 is the wide area network. PAN, it is the network very personal to users, such as a Bluetooth-enabled device. Its connect range up to 10 meters. Next is the LAN, a network that covers a small geographical area, such as single building or campus. A local area network is a network that typically covers a small geographic area, such as a single building, office, or campus. LANs allow connected devices like computer, printers, and the server to communicate and share resources within the same location. They are commonly used in the home, schools, and the business to facilitate internal communication and resources sharing. LANs are usually connected using Ethernet cables or wireless technology, providing fast and secure data transfer within the network. The wide area network, a network that spans a large geographical area, often connecting multiple LAN across the city or countries. Wide area network is a type of network that covers a broad geographical area, connecting multiple LANs and other network across cities, countries, or even continents. One use of various communication technology, such as less lines, satellite links, and internet connection to transmit data over long distance. They allow organizations to establish the connection between remote location and provide access to centralized resources and services. Ones are essential for enabling communication between geographically dispersed office, branches, and users. Next one is the metropolitan area network is the MAN, a network that covers a larger area than a LAN but a smaller than a WAN, typically within a city. A metropolitan area network is a network that falls between a local area network and a wide area network in terms of geographic coverage. MAN cover a larger area than a single LAN but are typically confined to the specific metropolitan area such as city or town. They are designed to interconnect multiple LAN within the same metropolitan region or facilitate communication and resource sharing among different organizations or campuses. MANs often rely on the high-speed connection like fiber optic cables or wireless technologies to link various network segments across the metropolitan area. Based on connection, computer networks divided into two: the intranet and the internet. Intranet is the use to specific group of user. Internet is available for everyone. Next is the network topology. Topologies is the design or architecture of network. It will determine how devices are connected in a network. Network topologies is classified into two: the physical topology and the logical topology. Physical topology shows the structure how devices are connected physically inside a network. Example are the cable wires. Logical show the logical method of communication. Types of topology. Bus. In a bus topology, every devices are connected to single cable. Star. In the star topology, every node in a network should be connected to central switch or hub. The ring link the node through a point-to-point connection over network. Mesh involves point-to-point connection between every node in the network. 3 is the connection of the star topology. Hybrid topology is the combination of two or more topology. I can show you today the Cisco packet tracer so I can identify you which one of this is the bus topology, the star topology, the ring topology, the mesh, and the tree. The first in this side, did you see? Where's my cursor? This 1, 2, 3, switch, and 3. This is the bus topology. It is connected by itself. Next, this side, this one is the star topology. As you can see, is a one switch is connected into 6, I put it here, 6 PC or more. And this side is the mesh, is a ring topology. I have 4 switches here, and connected to each of the 4 switches is connected from one, you can see, and I have 4 PC. This side is the mesh topology. As you can see that the mesh topology is connected from the, it's just like the ring topology, but the connection is from here to here. Did you see? From server to server. See, I connect here from this one to connect here, and then this one to connect here, and the PC is connect here and can transfer also here, and this one go here. And this is the what we say tree topology. There is like a tree that there is a branches. I put here, this is the one, and I put another one, and they are connected with also the I have a PC. So now, as you can see, I don't have a hybrid, but the hybrid set can connect two or more switch. So we try to connect the switch from the 3 to this, the ring topology. From 3 topology goes to the ring topology. So here I put a cable. I want to connect the 3. I'm gonna use this crossover copper wire. This 3, gonna try if can connect it here. Oh, see, we just wait, and I connect also 2 or more. So I'm gonna try this PC, the mesh, going to the star topology. So you just wait until it becomes green, because it means that it's still not processing. So from this star topology, I want to connect in the bus topology. So as you can see, it's already green. It takes for a minute before it goes to, and they said 2 or more. So maybe we try to connect also the bus going to the star. So here we go. As you can see, they said that the hybrid can connect more or 2 devices. See, I already connect from here, going here, from the ring to ring, then ring to bus, then I connect also the star going to bus, and the mesh going to the ring. So that's it, the hybrid for the explanation. Hope you have understanding of these classification types of physical topology. The next one is the network models. There are two network models. The first one is OSI model, the Open System Interconnection models. The next one is TCP or IP model. OSI model is the reference model which is developed by OSI. It describes data communication. OSI model is a 7-layered architecture. TCP or IP is the implementation of the OSI model. Network address is a logical or physical address that unique identifies a host or a machine in the telecommunication network. Is the address reserved for the network itself. Broadcast address is a special type of IP address that is used to send data packets to all devices on the network simultaneously. When a device sends packet to the broadcast address, the packet is received and processed by all devices on the same network. The gateway address is a router interface between the local network that sends packet out of the local network. Logical gateways address. The gateway operates at the network layer which is layer 3 of the OSI model. Physical gateway address, the gateway operates on the data link which is layer 2 of the OSI model. And now let's proceed to the part 2 of the course project. And it was given here the network address, the binary of IP address, the prefix length, subnet, and the gateway broadcast. And you can see the number 1, 2, 3, 4, 5, 6, 7, and 8, 9, and 10. So let's proceed for here are the answer for the part 2 questions. And now I'm gonna proceed for the explanation and the solution. Now is proceed to the solution and explanation. Number 1 is a subnet mask. This is given, the 225.225.225.224. So as you can see in my solution, that it's definitely one by one, so you can understand. 225 is the 8 bits, that's why 1111. So 128 plus 64 plus 32 equals 224, 8 bits. So since 3 times 255, that's why 8 plus 8 because 8 bits, 8 ones, 8 plus 3 because there is a 3 number. That's why it's become 27 is the answer. Network and the network address. Number 2 is the network address 172.201.95.32. The 8 bits is 11111 equals 128 plus 63 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals to 225. Number 3 is the subnet mask is 255.255.255 equals 128. So like in number 1, but 128 is you can see that have an arrow going to 1. The number 1, just add the 1 and the 28. That's why it's become the subnet mask is 225.225.225.128. So number 4 is the 10.10.78.128 plus 1 equals 29. The gateway is 10.10.78.29. I just add 1 for, so it become 29, which is like you can see here in the subnet tree. Next one is the number 4 is the network address. Sorry, number 5 is the one, the given address, the given network address is 192.8.84.35.0. So I show you how 192 minus 64. So 192 is greater than 64, that's why it's become 1. Then 64 is lesser than, greater than 32, that's why 1. So 64 minus 64 equals 0, so 0 0 0. So in 84 also is 84 is greater than 64, that's why 84 is lesser than 128, that's why it's become 0, but 84 is greater than 64, that's why it become 1. And 20 is lesser than 32, that's why 0. So 20 is greater than 16, that's why 1. And 4 equals 4, that's why it's become 0. It's the same explanation with the first column. Let's proceed to number 5. The network address, the given is 192.84.85. So 192 is greater than 64, that's why it's become 1 here. 64 is greater than 64 is here, so, and the 0 is, as you can see, 64 is greater than 32, 0 here. So 84 is lesser than 128, so that's why I put 0 here. But 84 is greater than 64, that's why 1 here. So 20 is lesser than 32, that's why 0 here. 20 greater than 16, that's why 1 here. And 4 is lesser than 8, so 0 here. Then 4, then 1, that's, and 0 0. So in 235 also is the same explanation with this. If you listen, you can get it. Number 6 is network address 192.84.235.0. It bits is 1 2 3 4 5 6 7 8 ones, and then 1 equals to 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. The broadcast address will be, I just copy it, 192.84.32.235.255. Let's proceed to number 7. Subnet mask will be 255.255.255.92. As you can see in the table that it's I given already the solution. And number 8 is 172.99.184, that's 82. And the broadcast address is 172.99.84.84. That number 10 also. Network address, the same as explanation to the other table shown. The 255, I repeat, 255 is greater than 128, sorry, that's why it's become 1 and the binary. 128 is greater than 64, that's why it become 1. 77 is 64 is greater than 32, that's why 0. 13 is lesser than 60, and that's why 0. So 8 is less than greater than 5, that's why 1. 5 is minus 4, 5 is greater than 4, that 1 1 is 0, so that's 1. It's the same explanation if in the other table. And the number 10 is the network address is 205.36.72.56. The 8 bits will be 8 ones. It equals to 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 225. The broadcast address will be 205, 36, 72, and 225.